Now we're going to look at what I call mixed gas problems. In this case, the relationships are all still the same, so we're working with the same ideas that we were previously. However, in these types of problems, we're going to be changing two variables, not just one. So we're going to jump straight into some practice. So the first thing you need to do is read the question and identify what information you have, because you won't always have information for all of the columns. Some things will still be held constant even if you're changing two variables. So you have a container with 10 puffs of gas at STP. Okay, so let's start with what we have. So we have 10 puffs at STP. So 10 is our number of particles. STP, remember, I'm going to use 1 atmosphere just because I like 1 better than 760. And standard, so that's standard pressure. Standard temperature is 273 Kelvin. What will happen to the pressure, so that's what we're looking for, if you add 5 puffs, so we're up to 15, and increase the temperature to 298 Kelvin. Okay, so looking at all of my information, I know nothing about volume, so I can assume that volume is held constant. So now I went from 10 to 15, so N went up. Temperature went from 273 to 298, so that went up. So if I look at each of these effects separately, temperature went up, so pressure is going to go up. Number of particles went up, so my pressure is going to go up. So I draw two things in that pressure box because I'm looking at each of those effects. Okay, so I'm going to start with pressure. 1 atmosphere. In this case, I'm just going to chain together my different factors. So I'm going to have 2 because I'm changing 2 things. So let's start with temperature. Temperature went up, so pressure is going to go up. So we're going to put the big number on the top. So 298 and then 273. So that's the same as what we did in the PT problems. Temperature is going up, so pressure is going to go up, so the big number goes over the small number. For our second one, we're going to look at N. Our number of particles went up, so our pressure is going to go up, so our big number is going to go over our small number. So 15 over 10. And now all I have to do is solve. So 1 times 298 times 15 divided by 273 times 10, and we get 1.64 atmospheres. So both caused it to go up, and it did overall go up. Okay, let's look at example 2. You have a 2-liter container at 300 Kelvin and 2.2 atmospheres. What will the new volume be if you are at STP? So STP, remember, is 1 atmosphere and 273 Kelvin. So my temperature went down and my pressure went down. So how do each of these affect volume? Well, if our pressure is going to go down, our volume is going to go up. And if our temperature goes down, we know that cold things contract, hot things expand. So if it's getting cold, it's going to contract, so our volume is going to go down. So we're going to start with our volume, 2 liters. We know we're going to have 2 factors. Let's do pressure first. So our pressure is going to go down, so our volume is going to go up. So we want the big number on top and our small number on the bottom. And since our temperature is going down and our volume is going to go down, we want the small number on top and our big number on the bottom. Now all I have to do is the math. So 2 times 2.2 times 273 divided by 1 times 300 gets me 4.0 liters. So the bigger effect was the pressure going down. The temperature had less of an effect.